Okay. So next session is about Kubernetes. We will introduce with Kubernetes. First, before we understand the Kubernetes, we need to understand what is the problem statement. So all the container runtime which we are using it, they are designed to run on a single host only. Okay. So let's talk about Docker because that's the only thing we are covering in this session. So Docker limitation is it runs on the single host only. So all the container which we are running, they are limited to the single host only. So it means that is not a production ready thing. Scaling, load balancing, clustering is not available, correct? So container across cluster is a limitation now. We cannot do it if I'm using only Docker. So there are multiple solutions available in the market. One is Mesosphere, that is orchestration engine, and second one is Docker Swarm from the Docker, and third one is Kubernetes. Okay, so we need a orchestration engine which can manage the container runtime and that too across the cluster. Okay, so orchestration is the solution. So we will try to understand why we need orchestration engine, what features it is going to provide it, what is Kubernetes, what are the other solution alternative of Kubernetes, correct? So first and foremost thing, Kubernetes is going to provide us a clustering environment where the master node will be there and worker node will be there. And in the master will control the worker node and all the workload will be running on like all the workload in the sense the container will be running into the worker node. Okay, that's cluster environment will be provided. Okay, so we will have a pool of server which will be running the Docker. Okay, if we don't have the orchestration engine, how will we manage it? Think about a second. If I'm not using any engine and I want to manage the containers across the host, how will I manage it? How will I do the scaling? How will I do the load balancing? So the task, manual task or writing the automation will not help me out. So to address that thing, the management, scaling, load balancing, clustering, this becomes a challenge. To address that thing, rather than sending the request to each node, we will have a centralized point where container orchestration engine is running. We'll submit the request there, and that will do the scheduling, resource management, clustering. So basically, we will have a pool of server which will be creating as a logical unit. Okay, and container orchestration engine will take care of that logical unit. Correct. So we have a lot of solutions available as Kubernetes. Kubernetes is designed by Google, robust. There are years of experience behind that. There's a one of the reason that is a market adoption is so high. Second is Docker Swarm. If I'm using Docker as a container runtime, then it is a very good solution. But other container runtime, it will not work that smoothly. Third one is Mesos, that is a Apache product. That is orchestration engine. It can do the orchestration for Hadoop job, batch job, and Docker container runtime. So for container runtime, the framework which we need to use is Marathon, but it's not dedicatedly designed for Docker only. Okay. So let's discuss about what key feature it is going to provide. All the container orchestration engine. All the container orchestration engine is going to provide is clustering, scheduling. Okay. Container as a service, like we say that infra as a service, same way container as a service, dynamic provisioning, horizontal scaling, load balancing, fault tolerance, and release strategy. Okay, all this thing container orchestration engine is providing it. Now question comes, why Kubernetes? First of all, Google has created this, and seeing their research and development, lot of people, lot of organization automatically interested in that because the kind of product they have created in the past, that is one of the reason the adoption is high. The internal name, project name was Borg, and Google has open sourced this one. Now it is managed by CNCF, that is a foundation which manages the Kubernetes. Lot of features are there. Now they are using Runc as a container runtime. Red Hat OpenShift, which is the one of the very famous container management tool from the Red Hat, that is also using internally Kubernetes for container orchestration. Okay, little bit history. As I told, it is developed by Google. Borg was the product name, developed internally by Google. And they have released a part of that, and it has Kubernetes. Kubernetes is now open source, managed by community, and the foundation which manages CNCF. Okay, so if I say what is Kubernetes, simple term, Kubernetes is a open source container management tool. What Kubernetes capability it provides: automatic deployment of container, scaling of application in the container format. Okay, capable of managing the container across cluster. Okay, it's a Kubernetes is going to provide a container centric infrastructure to me. Kubernetes can run multiple application, run application on the like on a run cluster on the physical or virtual machine as well. Like it can be physical machine where you can create the clusters, or maybe a virtual machine as well. So basically, the whole target of Kubernetes is move from the host centric approach to the container centric approach. Okay, and Kubernetes, the minimum unit of deployment is pod. Okay, let's discuss about architecture. So Kubernetes has master and worker node, client server kind of architecture. You can have a Linux machine as a master. Master has a key component. One is etcd, that is a key value database, API server, scheduler, and controller manager. Okay, so worker node, again, it's a Linux machine. Okay, there you can have kubelet service, kube proxy service, and docker contain or container runtime should be installed there as well. Okay, so this is the overall architecture of Kubernetes, where you have the master have the etcd, API server, scheduler, controller manager, and you can see the worker node where the container runtime. Currently you're seeing Docker image because that is a container runtime. We are using kubelet. Kubelet is a service which is going to communicate to the master. Whenever master wants to send the you can say request to the worker, or want to communicate to the worker node, they will be communicating to the kubelet. And whenever the kubelet performs some task and then it wants to respond it to the master, kubelet will talk to the master. So kubelet is the entry or exit point for the worker node. Okay, and kube proxy is for networking purpose. When we will discuss pod to service networking and service to pod networking, we will discuss in detail what is kube proxy. So this is the overall. So basically, when the end user wants to communicate to the Kubernetes master, API server is the endpoint. When you want to command line user UI or CLI, you will be communicating to the API server only. Okay. So what API server? API server validates and configure the data, validates and configure data for the API object. So each object in Kubernetes is REST API based only. Okay, so whenever using command line or using kubectl command, we want to communicate. The first communication point is API server only. API server service REST operation and provide the front end to the cluster. Okay, API server is a component of the Kubernetes master control plane that expose the Kubernetes API. Okay, it can scale as well horizontally. Next point is etcd. As you say, etc plus d. etc, everyone who has a Linux background, etc store the configuration file. Okay, d is for distributed system. So whatever metadata of this Kubernetes cluster or cluster status or object creation, everything will be going to store into etcd. And who will communicate to the etcd? API server. Only communication will happen etcd to API, API to etcd. No other communication, no other component will communicate to the etcd server directly. Okay, stores the configuration data. As I told, this is used to service discovery and cluster management. Kubernetes persists cluster state into etcd. Master always keep monitoring etcd and roll out the critical configuration changes. Other than that, etcd, you can use Zookeeper and console as a other solution for Kubernetes metadata or your cluster status thing. Okay, then comes to the kube scheduler, the control plane component that whenever I want to create a new workload, or suppose I want to create a new pod, which node it should go, who will take this call? Kube scheduler. How it will take them? Based on the hardware software policy constraint, affinity anti-affinity rule policies, and data like interference and deadline, all the component, how we configure it, based on that it will take a call. Next is controller manager. So controller manager has lot of things. We have node controller, job controller, endpoint controller, service account controller, token controller. So there are a lot of controllers are there, and each controller has its own role. Okay, simple term like node controller responsible for noticing or responding when the node is go down. Same way for job controller, when the job ends or job completes the task, that take care of node control job controller. Endpoint controller will point out the services to the endpoint, particular endpoint automatically. So these are the controller. Now kubelet, an agent that run in each worker node, okay, in the cluster. Kubelet takes a pod spec, and whenever master send a pod spec, based on that it will perform the activity and run the pod. And kubelet doesn't manage the container mm, which were not created by Kubernetes. So kubelet only manage the container which is managed by Kubernetes. Last and not least is kubeproxy. Kubeproxy is network proxy that runs in each worker node, correct? Kubeproxy is the maintains the network rules. As simple as that, you can say that kubeproxy works using the IP tables kind of mechanism only. Okay, so rules how we specify which how the traffic should go, how the traffic port forwarding should happen, how the IP forwarding should happen. All these things we control using kubeproxy. That is it about the why Kubernetes is required. I know it's a little bit faster, but this is uh, in interest of audience only. And now we'll go and discuss about how we can deploy the Kubernetes.